we can fit in our conversations into the hour. My job, along with Hannah Long, who is a important uh, organizer for this event, is to try to keep us on time as much as possible. So we may have to intervene uh, both during the presentations, but also during the Q&A to make sure we're on time. All right, so let's get to it, shall we? All right, so our first presenter is Kirstie Segarra. And Kirstie is a senior lecturer in structural integration at UNM-Taos. So please welcome Kirstie. I think there's your presentation. Thank you, Kirstie.
Yeah. Oh, yeah. You're welcome. Can you hear me okay?
All good.
Okay. So I am sharing some research I did in my private practice. Initially, was for a summit out of Rio, and they actually ended up canceling it. So what I was curious about was the effects of treating PTSD and CPTSD in manual therapy. Structural integration is a form of manual therapy that interweaves um, psychology in some forms with touch therapy. So this is why I'm calling it somatic touch. And then hopefully I can get to the next slide. There we go. And one thing I wanted to just kind of bring forth is structural integration works a lot with the connective tissue of the body, and 40% of the nerves in superficial fascia are sympathetic and have efferent pathways um, signaling to the brain and the limbic system what's happening in the environment. And there's been a lot of hoopla around the vagus nerve in the last few years. And I'm just kind of like, well, what if it's not just the vagus nerve? And then just to bring forth that soma is the Greek word for the physical body. And that's one of the reasons why we're using that terminology. And then defining what somatic touch is because it's a little bit more than just like massage therapy or a lot of other forms of manual therapy. That this is where I'm also bringing forth that some of the things I learned from the study was there was a high amount of neurodiversity and autism disorder with the females that I surveyed in the study. And somatic touch is the ability of the practitioner to listen empathetically, layered palpation inclusive of connective tissue, aka fascia, supporting downregulation of the nervous system and treatment of the circulatory system and support health as well as vitality in the client's system is how I'm defining somatic touch. And I sent this out in spring of 2024 um, and asked them to answer just a long survey with a bunch of different questions who had received 3 sessions. And the abstract here is really just pointing to the fact that 7% of the population um, is affected by PTSD and complex post-traumatic stress disorder. And what I was measuring was really structural integration and osteopathic manual therapy. And the method was just sending the questionnaire out. They answered the questions, and out of the 25 people I sent the survey, 12 completed the survey. And what the types of traumas were 16% accidental, 33% interpersonal, and 50% was a combination of interpersonal and accidental. And the results were a reduction in the symptoms. So we had 5.25 symptoms associated with traumatic stress and an average of 2.91 physical symptoms. The participants reported a 93% rate of experiencing great relief from somatic touch, with a reduction of 2.25 out of 5 potential psychological symptoms. In addition to PTSD, CPTSD, 33% of the participants identified as neurodivergent, neurocomplex, and with ASD. So that was kind of an interesting side note. The importance of overlapping symptomology co-concurrent with PTSD and CPTSD offered an understanding of how a neurodivergent and neurocomplex person experiences sensitivity and it has more neuronal connections in neurology, Overall, the results were supportive of somatic touch as an effective form of support to PTSD and CPTSD. And of course, because it's not a large sample size, more uh, research is warranted. And then this is just to define the slight difference because it's not in the DSM-5 yet. CPTSD isn't, but PTSD is. And so with the upper symptoms over here on the upper right are the added symptomology for folks at this level. And then the the PowerPoint I'm sharing right now is actually from a longer presentation. But my curiosity really was, does this work even work? I mean, I had a hint from having worked with so many people with PTSD and trauma backgrounds, but I was just really curious if it was effective or not. And I'm happy to just report that it is. And my hope is to do a larger survey down the road and increase some more awareness around the effect of touch therapy as opposed to talk therapy as a way of treating PTSD and CPTSD. So I'm going to end it right there so I can ask questions. I'm keeping it short in respect of time.
Thank you, Kirstie. Yeah, so please raise your hand and on the screen, like we're using the raise the hand function. You
Yeah.
can certainly text in your message as well if you want in the chat as well. Well, I'll go first, I guess.
Okay.
So
Okay.
Kirstie, so how do you do a sample? How can you get a representative sample, in work like this? Um,
Well,
okay,
so there is a bias because I surveyed my clients, right? So what I would probably have to do is reach to a broader pool of practitioners and have all of us send the questionnaire out to a broader set and then take that information in from there. And that would be that's probably the next step. So working, and specifically my curiosity was about measuring how the connective tissue, the fascia in the body, because of the high innervation of um, the sympathetic fibers going up through the ANS, and then it works with the limbic system. So another piece of this presentation that I'm not getting into is the periapital gray as a modulator in the limbic system for assessing like the environment of whether or not something is safe or not safe in the arc of sympathetic into parasympathetic with the fight, flight, freeze, flop pieces. So there's a deeper dive into this for sure. I don't know if I'm answering your question or I'm going down another rabbit hole, which is my tendency as a neurodivergent person.
it's interesting though because the challenge is when you have a smaller sample. If you know that, I mean, is that sample more likely to participate in a study like this because they've seen positive results? And I'm
Yes.
curious, how could you possibly get a sample that's more representative um, on that, given you know the likelihood that you probably have to use a convenience sample, right? Is the most
Yeah.
likely way forward.
Yeah, and I think it would be great. I mean, if I can carve out the time to do that over the next year or so, um, this has kind of just been my own curiosity for fun.
Right,
I'm doing this for fun. It's
right.
not funded. So yeah, but I think there is a possibility because I'm connected with enough practitioners nationally and internationally that I think we could maybe devise a survey that goes even broader. Yeah.
That'd be great.
Yeah, I think it would be, I'm curious. I'm thinking about it right now. Because that way I can do a better peer-reviewed article to have it published, and that's kind of part of the goal with this. So this was the first step, and then hopefully I'll be presenting at the Fascial Research Congress in New Orleans in August with this work.
The question from Roseanna in the chat.
Yeah. So what are the established healthcare systems that provide this care? Um, well, mostly structural integrators are in private practice. And then with the osteopathic manual therapy is more international because of the change of how osteopaths are trained now in the United States. They're more like prescribing physicians than they are manual practitioners. But initially, osteopathy was more fascial based and a manual form of treatment. And then see what are the strategies employed to integrate and promote this treatment within the medical and psychiatric practice. I don't think there is yet. I think we're still more on the fringe. The structural integration program we have up in Taos is the first one in a university, and there's only 15 about schools globally in structural integration. It's known as, a lot of people know it as Rolfing. Dr. Ida Rolf was the founder of that lineage of work, and that's one of the goals is to bring the work to more people in the long run. And so having a program at the University of New Mexico is really quite unique and is like a stepping stone to meeting those goals. Yeah. Any other questions?
So
Think
how
I've
old is
been,
the program? Uh,
um, I started working on it in 2017 to build the curriculum, and we launched the first cohort in 2020. So yeah, it's new. But I come from I started the massage therapy program up here in Taos, started working on that in like 2007. So taught in that paradigm for a very long time and was supported by our administration and Dr. Archuleta to develop this program and as a like an advanced tier of the work. So it gives a place for our graduates from massage therapy and our holistic healing arts certificate to come in and do a more advanced form of work in training. Yeah, it's quite unique.
well, as Randy Archuleta just said, thank you for representing UNM-Taos and the program. It's really great to learn about such an innovative program at our branch campus.
Awesome. Thank you for having me. I
Of
appreciate it.
course. Well, thank you,
I'm
Kirstie.
excited to share. Yep.
So next up, we have Andisheh Dadashi, who will be presenting, and she is a assistant professor in computer science at UNM-Valencia. Getting her,
Everyone, do you hear me?
yep.
Okay, so I'm going to start my time. So I'm Andisheh Dadashi. As you mentioned, I'm assistant professor of computer science, statistics, and mathematics at UNM-Valencia. So today I'm going to talk about the evolutionary basis of rapid phenotypic evolution of polygenic traits in changing environment. So what is polygenic or complex trait? Those are the phenotypes that are governed by many genes at the same time. They are complex. They have many components. So most of
Andisheh,
yes.
sorry, did you mean to share your screen?
Oh, I did? I didn't.
Not
Okay.
yet. Okay. No,
I'm
sorry to
sorry.
interrupt.
That's okay. Sorry. Thank you. Is that showing? Yes. Okay. So polygenic traits are the phenotypes that are governed by many genes at the same time. They are complex. They have many components. And most of natural systems and even human traits, most of our diseases, condition, everything are complex and they are polygenic. So it's important to understand this complexity and the genetic basis of this polygenic trait. Why? Because population and organism are rapidly adapting, changing, and switching phenotypes in response to environmental shifts. And this is actually happening in a very short evolutionary time, especially under climate change nowadays. So we must know how these polygenic traits are changing, evolving genetically over time in a long evolutionary time, and we call that phenotypic evolution. And we want to know what mechanism like selection, mutation, drive this phenotypic evolution. Currently, we don't have that much information about that. We need to understand this phenotypic evolution so we can predict inheritance pattern. And for example, here in this picture, you see that in textbooks, they are telling us the distribution of phenotypes changes very slowly in a small shift. But in reality, actually, we are looking at a very drastic shift in distribution of phenotypes. The most dramatic data on this rapid phenotypic evolution is in agricultural manipulation by strong artificial selection. For example, we see that in wild, like in jungle, the wild birds produce 10 to 15 eggs per year, but the selected domestic chicken produce up to 300 eggs per year. And then we see that, for example, domestic selected cow produce 20 times more milk than the indigenous cow. So we also observe some dangerous rapid evolution. For example, antibiotic resistance, biological invasion, and even microbiome, which plays a very important role in human body. They actually rapidly adapt. So we understand that this rapid evolution affect human body directly, and it's actually very costly for lots of countries. So now rapid adaptation is said to become a very important factor in shaping inheritance pattern and diversity, especially during now global climate change. In some of the species, we see that the timing of their reproduction, seasonal reproduction, has changed. And with this, facing this global climate change, global warming, some population either must adapt or they have to vanish. So that's why we need to understand the mechanism that caused this rapid phenotypic evolution, to be able to make the predictive model, to be able to find out when this dangerous rapid adaptation happened, when the good one happened, to be able to protect some of the population, because some of the population have a better chance of surviving. So how do I fill this gap? I use computational framework to understand this rapid phenotypic evolution in complex traits. The complex traits has governed by many genes. So I use population genetic approaches in like quantitative genetic setting to create a stochastic model. It's like a simulation, a theoretical model that can simulate the evolution of complex trait. So I assume a finite population of many individuals comprised of like a large array of genes, and then I let this system to evolve in silico in a long evolutionary time. And this is very computationally, very intensive work. I have to use parallel programming on computer clusters. So I observe these changes in phenotype, and I measure some genetic parameter in silico. For example, expected heterozygosity. What is that? That is the how diverse locus is in the population. So when I say locus, I mean gene. When I say allele, I mean the form of gene. And then I look at the fixation probability, fixation time. These are the probability and time that new mutation get fixed per locus in the population. And when I say fixed, I mean all the genes in the population have the same form of And then I look at allele frequency distribution, and that gives me a kind of idea about the genetic marker of the population. I look at the polygenic variation, that is how overall variance across all the loci evolve over time. And these are all promoting and giving me information about the rapid adaptation. I look at the changes in fitness. When I say fitness, I mean how the individuals are doing, fitting, they are surviving in a population, in the environment, in an evolutionary sense. For example, high fitness means the individuals are surviving better. Lower fitness means they may, get removed from the population. And then I let my simulation to run forward in time under some evolutionary forces like mutation, selection, reproduction, recombination. And then I will look at those genetic parameters that I just mentioned. So I look at some different environmental scenario. For example, I look at the slowly continuous shift in the environment, and that is the shift that is happening gradually over time. For example, the change of participation, the weather, the climate change is a slowly continuous shift. And then I look at the sudden environmental shift that is happening whenever we have an earthquake. Population have to adapt, right? So these are the environmental changes that I look at, and I look at the changes of phenotype or rapid phenotypic evolution under these environmental changes, and I want to see what mechanism, like selection, has a more effect, or mutation. So yeah, this is the research I'm doing. Thank you so much for your time. It was very difficult to wrap it up in 7 minutes. I usually have 25 minutes to, present my research. Sorry about that if I was, too fast. Thank you, everyone. I welcome your questions.
It's a tough one. That's hard to get in 7 minutes, but thank you for doing that. Any questions? And I'll ask a question just to get things started. Oh, here we go. Roseanna, how did you develop your methodology?
Well, first of all, so I should mention that I was not a biologist. When I came to this field, I was thinking about all the information and all the knowledge I have about computer science, about, statistics, because this is a mixture of data science and computer science, and these are my field. And then slowly, with the help of my advisor, I digged into some, biological aspect of this. And then slowly using my, knowledge of computational, knowledge, I created the model. And well, it was not that easy. But yeah, based on some of the population genetic information, I was able to create and assume, how the computational aspect of this can work and how I can assume the simulation. And then how large are the population that you model? Okay, so when I mentioned that this is very computationally intensive work, I meant that, I really meant that, because sometimes one population that I run, which is just 1,000 individual, takes 2 days. And we have some limitation. We are using this HPC, which is high performance computing, or CAR-C, and we have limitation of just running our code for just 2 hours. So each of my code can hit the kind of wall time and stop without giving me any result. So I have to limit my population to lower number than 1,000 to be able to, run my code and not hit the wall time and not, be kind of fail to get any result. Yeah, the maximum is, let's say, 1,000 of individuals. And
Thanks.
each individual actually comprised of sometimes 500 loci.
So what are your next steps, and what do you hope to do next?
So for right now, I have 2 papers that I'm working on. One of them, I'm looking at the temporally varying shift in the environment, which is the seasonal shift. For example, population are facing all of a sudden cold environment in one season and all of a sudden very hot environment, and they have to adapt, right? I want to see what kind of evolutionary force has effect on this rapid phenotypic evolution. So far, selection has a very strong kind of effect, even though the population genetic people are thinking that mutation has the highest effect on rapid phenotypic evolution. But we figured out, I mean, our hypothesis was that selection can have an effect. So in this temporally varying shift environment, also we are testing to see if selection has effect or mutation. And then so far, selection has some effect and can do its job. One of the environment that I just talked about was, I mentioned, was continuous shift in the environment. So there are two different environments that now I'm, working on.
Thank you.
You're welcome.
Any last question? All right. Thank you, Andisheh. Appreciate it.
You're welcome. Thank you.
Okay, so we welcome next Jerry Godbout, who is an associate professor in chemistry, also at UNM-Valencia. Welcome, Jerry.
Try sharing. There we go. Okay. All right. Thanks for having me. So the title of my talk is Crystalline Glazes, a chemist tries to help some artist, and the subtitle is They Are in Fact Still Waiting. All right. Crystalline glazes, what are they? It is a glaze that makes something that looks like this. I don't know how well this picture is being broadcast, but their hallmark is these extended macrocrystals that are very needle-like and can be up to centimeters in diameter. There's a special type of glaze that you need to make these. And this is basically the recipe, although you probably don't care too much about the recipe. The important thing is, and this is what the FRIT is, that everything on this list is completely colorless, or it's white. So that is why this piece right here is white, because the porcelain under it, the special type of porcelain that you need, is also white. Now, these look neat, but if you put in, all right, so this is domestic porcelain. It's fired to not quite 1300 degrees Celsius. But if you put in a pinch of something like copper 2 carbonate, you get this, which is much prettier, but still has these extended needle-like crystals. And here you can kind of see them here. And when I first saw these, the thing that really interested me was that color is not dabbed on in specific places. This glaze is a homogeneous slurry, and it is painted on to the fired piece of porcelain in a completely even manner. Yet somehow the colorants aggregate. And I wanted to know how. And the other potters did as well. So, and just to give you some other examples about this, if you throw in some iron 2 oxide, you get this is a piece made by Jan Pacifico, our ceramics instructor, and I believe still available for purchase at the Tomei Art Gallery in Los Lunas. And there's a few other elements that you can put in there to impart some color. And again, this was homogeneously applied, and you can see there are areas where the crystals formed and areas where they did not, presumably because of a difference in the cooling rate after this thing was fired. And it turns out that there are a couple elements that work well for this. Adding a little bit of iron, cobalt, nickel, or copper. And so I happened to be taking this class at the time, and I thought, ooh, I'll put them all in. So I made a glaze that contained copper 2 oxide, cobalt 2 carbonate, and nickel oxide, and got this, and this, and that. And I was happy because I got lots of nice crystals, areas where there's not a crystals, and then again, the aggregation of the colored regions still fascinated me because I had no explanation for that. So what the potters would say is that, well, clearly this is probably the cobalt. So if you've ever seen blue cobalt glass, it's kind of the same idea. Is aggregating, forming these crystals. The greenish area here is probably from the nickel and the copper. And as a chemist, I fully agreed with that. I still couldn't explain why the colorization was so localized, especially in a piece like this. And these were all made at the same time with the same glaze. And I thought, ooh, I should be able to figure this out because we have one of these. So a couple of years ago, the National Science Foundation and National Department of Education bought us a lot of lab equipment, which was responsible for the nearly singular undergraduate student research program that we have at UNM-Valencia. So this is an X-ray fluorescence spectrophotometer, and it is useful for telling you what elements are in your thing. The X-rays shoot out an electron, and another electron falls in to get its place. It gives off energy. That energy is very distinct for each element. And so that the secondary X-ray fluorescence is analyzed, and you could say, oh, there's cobalt in there, there's copper, there's zinc, there's whatever. All right. So I ran to the lab during class and thought, okay, I've got this all figured out, or we'll have it all figured out by lunchtime. There have been many lunches since then. All right. So first I, thought, oh, there's probably, the cobalt, but it seems like, there wasn't a whole lot more cobalt in the blue regions than where there wasn't blue. And some of the results didn't match what you actually saw with your eyes, which led me to believe that this was probably a bit more complicated than I was expecting it to be. And so one of the complications is I am a horrible potter. So this ceramic, this glaze is known to be quite runny, especially relative to other glazes. And I could not make a flat plate. So the glaze pools. This X-ray technique, which is very easy to use, probes down anywhere between a few microns and a few millimeters. And the glaze can pool a few millimeters depending on how thick you put it on. But it might not. So like right here. So part of the problem is that we're going to get more signal if the glaze is deeper because there's more stuff. And to further complicate it, if it's probing down into the porcelain, that is also a completely different set of signals. So to get some accurate results from there, we needed to figure out a way to account for this inconsistent sampling depth, whether you're probing glaze or some of the porcelain. And so with the help of some very bright students, we figured it out. So this is one of the first pieces. And when we realized that there was a pooling issue, this was one of the first results that led us to believe that. That here, just taking scans from this center where there's not a whole lot of large crystals forming, that the signal from the copper went up, the signal from the cobalt went up, and so did the cobalt, and then so did the nickel. And we figured out that we would basically scale this to the zinc signal. Why was that? Zinc is the one element that is very, very prevalent in every formulation of this glaze, and not so much in the porcelain itself. So we'd interpreted this increasingly high signal because of the pooling, and once we scaled for the zinc, we found that actually it kind of leveled off a bit. And now that we knew that we could use that zinc signal as a scale for everything else, we did find that. So I got another minute left. So part D that said, there's a lot of cobalt there because of crystals. Sure enough, let's see, where is that? D and E, so these two large crystals have about 10 or 20% more cobalt than this area right here where there's no blue crystal at all. And that's where we're at. And now we just have to figure out a way to, now that we know that we can trust our signals, figure out a way to systematically make a couple different pieces so we can see how this aggregation starts. Time's up. I need to thank some people. I've had 3 students work with me on this over the last year or two. Jose Gonzalez, Carlos Bustillas, and Veronica Batista. Janice Pacifico is our ceramics instructor, who has helped a lot, and Science Foundation, Ed Department, and Valencia Administration for financial support. Thank you.
Thank you, Jerry. That's fascinating. Any questions? Feel free to talk too if you want to.
Yeah, I thought, Ooh, this project is fairly new. I should have no problem getting it to 7 minutes. I was wrong.
It's
Um,
always a challenge.
and this has been, so I've made some of those pieces there, and that is a humbling experience. I am not good at making things out of porcelain.
Rosanna has a question. Have you tried using a paint shaker before applying the glaze?
No, so these glazes seem to be very much a black art. From what the ceramics say, this usually works for me more often than not. And this is why, a vase that's about a foot high with a lot of these crystals can sell for a few $1,000s. It doesn't happen it doesn't happen easily. So now that I think I'm convinced that I can trust the numbers that we get, then we can start working about having some way of just systematically varying. I think the condition of the porcelain before you put the glaze on is probably one of the more important things where the nucleation can start easily, which is what you don't want, or delayed as long as possible, which I think is what gives you the nice crystals.
Julia mentions that this is Julia Fulgham, that this is a great way for students to learn about how hard it is to do analysis on real world samples. How the response to the students that you worked with, to this?
They like it. I mean, it's kind of a self-selected group, but yeah, so these experiments are not, this is perfect for our student population at Valencia. Because generally, I mean, they're ready to leave our campus by the time they're done with Gen Chem on average. This, it takes me a day or two to get them trained. Um, and so it's a real world, a sample they can see, so they seem to like it. They can appreciate some of the intricacies of, okay, what you read off the screen. There's a lot between what you read off the screen and what shows up on the nice pretty poster. In this case, that would be the incredible Excel template that Jose made so that to process the data from the instrument. Yeah. Thanks, Kirstie. Yeah, it actually has been fun interacting with, corners of the campus that usually don't do so. And that's been a big bonus too.
Have you thought about the roughness of the porcelain before the glaze is applied?
Probably, like I said, the rougher it is, I think the easier the nucleation is going to be. So, what I need to do is recruit some art students that can knock out a couple of plates a day, and I could not. But yeah, I think the prep on the porcelain is probably a big part of it.
Could you not make the vessels, or actually just have some that are pre-fired, or does it have to be fired before you fire it again, or you fired it
Yeah.
with the glaze, I imagine.
Oh,
Anyway,
these are fired twice. You make the plate, vase, or whatever, that gets fired, and then you hope and pray that it doesn't crack. And then you apply the glaze, put it back in. In this case, it pretty much under the same, at least the same final temperature. I think the temperature program is different. Now there are some people that can, as far as getting plates, there are some people on our campus that could knock out a plate in 3 minutes. I just need to recruit some of those to help out.
I'm curious about the industry here, because you imagine that the glaze makers have some sense of the chemistry behind it, or at least they've tested it. I wonder, but what's the prospects of a chemist working in the arts industry?
I would say if there was a chemist that could make the success of getting these crystals to grow higher, that they could probably live off that.
Well, they are pretty, and they probably go for a nice amount.
Mhm.
Any other questions? Well, this is great. And it's a great example of working with our students and providing these fun but also challenging types of experiences.
Thank you very much.
Thank you, Jerry. Okay. Well, last but certainly not least, our fourth presenter is Roseanna McGinn. And Roseanna is the director of our Health Information Technology program at UNM-Gallup. And there it is. Thank you, Roseanna.
Hi, everyone. So this is just introducing my idea, which is that healthcare administration industry trends need to be looked at, and an epistemological argument for designing an effective approach to using newer technologies needs to be designed, implemented, and discussed. And I am also a DHA candidate at National University, specializing in artificial intelligence in healthcare administration. Go ahead and advance the slide, please. So the epistemological argument, I'm going to be discussing today the trends in the healthcare administration industry, and that includes which newer technologies we are starting to see being utilized more frequently. There are three major trends that I will be applying this approach to. The first is artificial intelligence, which has three major definitions related to it: iterative, generative, and artificial general intelligence. The second trend is electronic health records, and the third is value-based healthcare models. And the fourth, arguably, is telemedicine. So we'll get into that as we discuss this a little bit more. But by applying an epistemological approach to the argument for the use of these technologies, we have to look at the evidence-based studies that overlap into these areas in healthcare administration. And, you know, it might seem kind of weird to apply philosophy to this problem, but we're all humans and humans need healthcare. And so that's why it's important to look at it from that human need aspect. Go ahead and advance the slide. So how do we get this kind of evidence? Before we start adapting a new technology or a tool in the healthcare field, how can we know if the idea of the technology is ultimately going to be good? So the first thing we have to do is define the character of the technology. And even though AI has shown promise and is doing very well, and maybe we can even use it to analyze large data sets, things of that nature, there's all these different speeds and variable outputs that AI can produce. And we need to start looking at what about its analysis process, how are we using it, and is the result going to produce something ethical? So the electronic health records, we're looking at the value-based healthcare models. They really rely on that healthcare record being electronic. To analyze these in any other way would be very slow in this day and age, especially since we've had electronic health records since the end of the early 2000s. The next task is to use the description to break down the statements about the new technologies that are currently being used in academic literature and philosophy in the technological fields, and see how many times these descriptions produce differences in logic. Next slide. So by defining the kind or the shared properties between the technologies that are trending in healthcare administration with a Venn diagram, it'll make it a lot more clear what words really just don't. And then I produced a table to sort the technologies into areas that overlap and belong together, with further illustration of their relationships of those technologies that are trending currently in the United States, and to assign a type or formally describe each tool and the function and the form of the tool, and to finally to compare these tools effectively and their effect upon the industry when compared to past technological changes. So those kind of changes were like the messy change from medical records from paper to electronic. It was messy because it was the first time we were really doing this. And without some of that uniformity and that adaptation of technology, you know, we're looking at a historical science way of looking at technology by producing a timeline. Next slide. So here's the Venn diagram. If you notice, you can see that I have different overlapping areas, and there is a place where almost everything overlaps, but EHR really doesn't. The way I produce this Venn diagram, we're going to look at that chart next. It makes it a little bit more logical. I was able to assign certain values to certain technologies. So AI only, in a Venn diagram, we're going to have areas where we only see AI, but we're going to also see areas where it overlaps into everything else. And what we haven't started to see yet is EHRs overlapping into AI. We are now starting to see that a little bit more, but it's just not quite there. Next slide. So right here, we have the timeline of changes in medical records and administration. So it starts in the 1960s with the introduction of SOAP notes. And you go through the 70s with terminal digit filing systems. It's a common way that we file medical records and keep things organized so we can find individual records. In the 90s, we started using electronic medical records. But in the 2000s, we codified their use, and it became almost a requirement for every industry. In the 2000s, the only industries that were exempt included industries like psychiatric. So there's a few reasons why, and it was mainly had to do with privacy. And even those, by the 2010s, we started seeing that had changed. But also we saw the beginning of AI and analytics and natural language processing in the 2010s. In the 2020s, we started seeing the expansion of telemedicine as a result of COVID. It was implemented more quickly. Next slide. So right here is the chart that I used to produce the timeline. So I kind of summarized what each time period was, and then I also broke things down by function. So if we utilize algorithms in the technology to assist in a medical diagnosis treatment, and the data analysis is used to enhance that analysis, decision support, and personalization, how does that overlap with EHRs? How does that overlap with telemedicine? How does that overlap with how we collect data and how we use that data, right? And so we start to think about how we might figure out how to improve our data management by doing these kind of models, right? A side effect of using ethics and the basis of that as developing this model is an advantage for potentially developing these things without worrying so much about profit, right? But the outcome actually may improve profit. And one of the cases for that is when we start seeing how we do data governance in hospitals. So that's kind of what gave me the idea to make this chart. And that's how I came up with these different functions and characteristics of the technologies themselves. Sure, I could add maybe a few more things into each category, but for a start, I thought this was a pretty good place to start. And electronic health records are probably the oldest technology on this list and the most encompassing, and probably the most potential to overlap with AI eventually, but just currently doesn't. That's just not the way it's been designed. So value-based healthcare provides data for quality assessment, and this is where it could increase profitability for healthcare industry who are looking for a reason to approach this in this kind of way, because you still need some sort of financial motivation for most hospitals, to make it something that they want to apply. Next slide. So over here is the overlap details for my Venn diagram. So I made the first chart and then I made this chart to make the Venn diagram. And you can see that we decide, or I spent a lot of time deciding if there could be overlap or not. And one of the things that I wanted to focus on is this value-based healthcare idea, because I feel like at the core of it, if you can make an argument for ethics and also make an argument that that increases your bottom line, that it's more likely to be implemented as a strategic function of a hospital's plan for technological uses and research and stuff like that. All right, so I wanted to conclude the use of artificial intelligence, electronic health records, value-based health models, and telemedicine are major trends that are transforming healthcare management and administration, much like terminal digital filing systems and SOAP notes transformed healthcare administration in the past, or how the switch from paper to computer-based records changed how we understand disease, injury, and treatments. And understanding history gives us insight into progress into the field. So by enhancing these trends and adding ethical guidelines and technological regulations beyond what HIPAA currently covers, we can improve patient outcomes in theory and practice, enhance efficiency, and ultimately deliver better care to those who we serve while keeping that data private and secure. And I got that information from Department of Human Health Services before the web pages had their issues. And before running full into the arms of change, we should be asking, what is the character, description, kind, sort, and type of technology we are utilizing? And are the risks manageable or mitigated by proper actions? Administrators should always ask the hard questions of ethics and philosophy in the case of technology, and through the use of rigorous application of ethics, technological evolution in modern times and human needs, we can produce better experiences, outcomes, and systems for the benefit of stakeholders and the communities we serve. When a man uses a hammer, the man is who chooses if the hammer is a tool of destruction or a tool of creation. Therefore, as administrators of healthcare, we are responsible for teaching and ensuring the proper and ethical use of modern medical tools of AI, EHR, value-based healthcare models, and telemedicine. Thank you.
Thank you. Questions for Roseanna?
Rosanna, I'm curious if you looked at AI only in like hospital settings and health center settings, or if the inclusion of like these newer or other medical resources like Amazon, you can get prescriptions and talk to a doctor through Amazon now, if that was included.
So I considered that to be telemedicine in that kind
Okay.
of instance. There's not too much debate as to if that is telemedicine or not. What the big thing I think is when you're billing, there you could bill for a telemedicine visit, or you can potentially bill for a phone visit. And so when you're an administrator, that's how you're making the decision of how you're defining the care setting, right? Is by deciding what code assignment in the CPT manual in the E&M section is applied. So that's evaluation and management section. And so that's like a visit. So that is something I did look at, but I didn't put a lot of emphasis on it because I clumped it with telemedicine.
That makes sense.
So I'm not sure exactly how to articulate this question, but what are the trends in regulation here that you can see in the near horizon when it comes to particularly AI? Yeah.
So have you guys heard about the Stargate project? Well, it's something that the Trump administration's kind of kicking around about artificial intelligence. And it has a lot to do with the kind of regulatory ideas and things that are going to be pursued by this particular administration. Now, AHEMA, the organization that I get my credential from, RHIT, and maintain it through, they go once a year to Hill Day. And this year, they have a strategic artificial intelligence implementation plan. And that is what they are going to be lobbying Congress for. If you are very curious, you might want to check it out on their website. But there are a couple heavy-hitting industries and organizations that are lobbying for certain kinds of regulations. But then there's also almost, from what I can tell from the Stargate, is that it's actually deregulation in a lot of ways. So it's interesting to be in this time and to see that the laws are really far behind what we actually need them to be right now, and how that potentially makes us vulnerable on a national security level. You know, if individuals' data is vulnerable, then our national security is vulnerable for our citizens. So I think that AHEMA is going to do the right thing and lobby hard. And I think other organizations will be there. I think doctors are starting to be more involved. Like, I'm involved with AIBM, and they have a lot of potential to be involved in this discussion. And there are starting to be more and more organizations that are specifically for this kind of intersection of technology. But I can tell you that I was in a meeting and a training, and it was being done by someone very respected at Stanford University. And one of the big things that I learned is that doctors are doing it anyway. Doctors are using it anyway because they're desperate to save lives or to save time or to save money. And I was kind of horrified to learn that some doctors were using ChatGPT to code ICD-10 and CPT codes and submitting those codes for reimbursement. I was horrified because I've never been able to get ChatGPT to assign a correct code in my life. And I've been trying because I think it's interesting. I've also tried Gemini. It doesn't do it. Perplexity sometimes will get it, but not usually. So there are real limits to what it can do right now that we're going to break through pretty soon. So it's a real race.
Thank you. The last question here. Well, thank you, Roseanne. That was actually a very timely presentation on important issues. And I'm sure we'll be hearing a lot about the regulatory picture coming up, so far as it exists. All right, well, thank you everybody here. It's really great to celebrate the work from our branch campuses, to celebrate one UNM. And thank you for being such a big part of the mission of the university and for extending our community to our students out there as well. We have another Lightning Lounge coming up in March on the 28th, so please be looking out for information on that. We have 4 other presenters who will be lining up, and we will have a Zoom invite for that as well, for those who can't come to main campus. Again, thank you all, and look at, we made it under 5 o'clock by about 40 seconds, so well done.
Thanks
Everybody.
Yeah.
Ciao.
Thank you.